Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now going to answer question number. Sorry about that. Okay, question number 8 from the specimen paper, paper 4 of the 2025 new syllabus. And this question here is about basically straight line graphs and inequalities and regions. Okay, so we still have inequalities and region in the syllabus. There's some doubt about that between certain people because it mentioned in the syllabus that linear programming is no longer in the syllabus. Well, this is not exactly linear programming. This is inequalities and regions. Okay, so that's still there, as we can see from the specimen paper, that it's still there. Okay, drawing the lines, shading, and finding regions satisfied by certain inequalities is still there. So part A says, on the grid, draw the lines y equals x and x plus y equals 7. So this is to do with straight line graphs. So if you want to draw the line y equals x, that's pretty simple. This is a very, very easy line to draw. We know that the x and y values will always be the same. So when x is 1, y is 1. When x is 0, y is 0. X is 8, y is 8. It's just going to be a diagonal line which goes through all the points where the x and y values are the same. So it's going to go like this. That's the line y equals x. You can also think about it as, we want to draw the line y equals x. It's like if you think about y equals mx plus c. The y-intercept is 0 and the gradient is 1. So it goes through 0 and the rise over the run is 1. So 1 up and 1 across. So we end up with, these points, join them together and continue the line. Okay. And the other line is x plus y is equal to 7. So how do we draw the line x plus y equals 7? Well, basically what we do here is we can do it the same way as I just mentioned here. There's 2 ways we could do it. We could make y equals basically minus x plus 7. We know that the y-intercept is 7 and the gradient is negative 1. So it goes through this point here, and if the gradient is negative 1, that means the rise over the run is going down 1 and across 1. So it's going to go through this point and that point, and then we join them together. But the easiest way of doing this type of question, when it's like this, I like to do it this way. X plus y equals 7. If you have x and y both on the same side, then we can say, let's find out what happens when x is 0. When x is 0, we know it crosses the y-axis. So it crosses the y-axis when x is 0. When x is 0, y is 7. So it goes through this point here. And we know that when y equals 0, it crosses the x-axis. When y equals 0, it crosses the x-axis. When y equals 0, x equals 7. So this is the point 0, 7, and this is the point 7, 0. So it goes through these 2 points. That's why I like to do this question, okay, in these type of situations. So we know it goes through these 2 points here. Okay, and we have our 2 lines drawn. So this is the line x plus y equals 7. Right, so there's the answer to part A. Now part B, it says region R satisfies the 3 inequalities. Y is greater than 0. Now y equals 0 is greater than equal to 0. Sorry, so y equals 0 is this line, which is the x-axis. This is a line, y equals 0. Y equals 0, that's the x-axis. And y is less than or equal to x, and x plus y is greater than 7. So basically, we need to label the region R. So it doesn't tell us to do any shading here. It just says label the region R. Okay, so there's no shading needed to be done here. We can shade if we want to. Okay, but basically, y is greater than or equal to 0 is above this. So somewhere up here, of course. Y is less than or equal to x. Okay, that's going to be related to the line y equals x. Now, y is less than x when you're below this line. And y is more than x when you're above this line. Okay, So normally what we do is we just take, the direction of the inequality sign. It says less than means below, greater than it means above. In most cases, that works fine. Okay. The only time that doesn't work is if y is on the other side of the inequality sign, or you have, your x term having a negative, right? So when it's something that's negative, for example, if you have y on this side but with a negative coefficient, then you have to kind of do the opposite. So basically, so that's one way. So basically, if the y term is on the left side, or if the y term is on the right side of the inequality, or if the y term is on the left side but has a negative coefficient, then we don't follow the sign. We do the opposite of that. We can rearrange it to put y on the left side and have it as a positive coefficient and then follow the sign if you want to, or we can even test some value. So for example, we could do something like this. We could say, okay, this is the line y equals x, right? So if we test a point, for example, if we think that the points below this line satisfy the inequality, we can choose points below this line. So for example, I could choose a point here, which is 1, 0. And if I replace the y with this point, which is the point 1, 0, the y is 0, and the x is 1, we can see it makes the inequality true. So this point is on the side that we need for this line. Okay, so it's the part below the line that we need, okay, that is going to satisfy that inequality. Okay, so if you were going to shade the unwanted regions, we would shade what's above the line. Okay, because we need what's below it. And here, of course, y is greater than 0, obviously is going to be what's above, so we shade what's below. And for x plus y is greater than 7, as I said, we follow the sign. So it says greater than, it means above. Okay, so we need the region above that. Okay, so this is the line here that we, so we don't need what's below, we need what's above it. So it's going to be, our region is going to be this region over here. Because it's, if we were to do the shading, let's say I decided to shade the unwanted regions, you'd see that this is what we're left with, because we don't want we want to get rid of what's below y equals 0. We want to get rid of what's above y equals x. And we want to get rid of what is, because it says x plus y is greater than 7. So we want what's above it. So we're going to get rid of what's below it. So we're going to get rid of what's below this line here. And you see the only thing we're left with is this region. Okay, so you can do it by shading if you want to, by shading the unwanted regions. Okay. And for this one, we can do a little test as well. We can say, okay, it says x plus y is greater than 7. So you can choose a point. For example, choose the origin. Origin is a nice one to choose if the line doesn't go through the origin. So the origin, of course, is 0. That's a nice, easy number, or nice, easy numbers to deal with. So you have x plus y is greater than or equal to 7. If I put 0 in here, we see that it makes inequality false. So that means this side of the line x plus y equals 7 is what we don't need this side. So we have to be on the other side. So we shade this side because it's what we don't want. Therefore, the region is going to be that side. Now, this question did not tell us to do any shading. All right. It doesn't say shade the unwanted regions or anything like that. Okay. So I guess it's better to leave it unshaded. Although if you shaded it, it would be perfectly fine. Okay. But it just says here, label the region R. So that is a region R. It's like an open region, it goes on and on. Okay, so there's it, question number 8, part A and B done. Okay, so this is all about, inequalities and regions, basically. This is under the topic inequalities and regions. And you will find that in the top right corner of the screen, at the end of this video, you'll find the other questions from this particular paper. And in the bottom right of the screen, at the end of this video, you will find questions dealing with inequalities and regions from my IGCSE collection. You will also find here a link that tells you how to subscribe to my channel, and here will be a link which takes you to a video which tells you how to use my channel in an efficient manner. Thank you for watching, and see you soon.